have never, in my 20 years of experience, I have never been in any project where developers came together, regardless of skill level. You could be talking A-list developers, all of them. Sit down, plan a project of sufficient complexity upfront, and that plan, as is, works from start to finish. Hey, Scott, how's it going?
Same old.
Nice. So, what are we talking about today?
Let's do some brain dumps and scattered discussion / debate on managing the software development effort for an organization.
Okay, not for a startup or any organization
No,
whatsoever.
I mean, it could be applicable, but
Okay.
I think most people don't work at startups. Most people work at mediocre companies or organizations.
Okay.
Mediocre means average. It is what it is.
Yeah.
So,
Average doesn't necessarily mean bad, although in today's world, people like to associate the two together. But regardless of what happens, there are always going to be averages. It's just where the average is depends on whatever it is you're measuring. But yeah, I
bell
digress.
curve. All right. So,
Yeah.
I'll just do a brain dump.
Okay.
It's going to sound like I have Tourette's. Okay. I'm exhausted, sick and tired of being on projects in which they say there's really no project plan, right? Like it's really like all right, here are our teams. Okay, here are our features. Okay, this team, we're going to arbitrarily assign them to work on this feature. That team, we're going to arbitrarily assign them to work on that feature. We're not going to get input from the actual architect that is held accountable for the architecture, in which Conway's law tends to influence the architecture based on the organization, um, how it's configured, right?
Mhm.
We're not going to have a discussion with the architect, and we shouldn't be surprised when there's communication issues with the architecture, with features, and with different teams. Oh yeah, and the only way that we've always been practicing software development is big bang, as in ready, set, go. Everybody, all teams, start banging on your keyboard now. Go, 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 go. Oh, and when we plan for projects, what we really do is we just do poker planning, and we're a team. Rah, rah, rah. Everybody is involved, and including junior developers that maybe never even really built software before, but their estimation counts as well. And everybody's opinion or estimate is equal, regardless of someone that has 20 years of experience of failing versus someone that has 0 years of experience, and they're just trying to be a team player and throwing out a number when asked. Okay. Thank you for letting me get this off my chest.
Yeah.
Oh no, I'm not done yet. Oh yeah, and when we estimate features, we're not going to even consider what's the prerequisites for those features. We're not going to consider what the actual architecture is and how those features plug into that architecture. We're not going to even consider that a feature is really a set of capabilities that realize a feature, and each capability could have a prerequisite or a dependency that needs to be implemented first, which means that for each capability in which there's a set of capabilities that aggregate into a feature, they should probably have unique identifiers. And we should, when managing the development effort, we should have a plan for this is what it means to deliver this feature. Here are all the capabilities, here are the dependencies for each of the capabilities. And in order for this feature to be built, these dependencies, aka capabilities, need to be implemented first. And maybe we need to have uh, a session or a design meeting on how we're going to attack this prerequisite in order to even begin feature development. These conversations, they're not had.
Mm.
It's agile, rah, 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 team, team, team. Let's arbitrarily assign people to features or tasks without designing the project itself, such as instead of we have 4 teams, ready, set, go, everybody start typing. No, no, no. Have a technical leader, aka architect, design the project. Within the project design, identify what are the feature enablers, hence the architecture that is going to support or provide a platform for features to be implemented, right? Is it really all the teams working in parallel? Go, 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 big bang? Or is it a staged uh, development effort where first you may have your architect and lead developer build out the foundation, the architectural components or the feature enablers, not features, but feature enablers, aka architecture, stage one, right? And then gradually allocate teams when the dependencies are now available and design the project before you start building the solution. And that's something that it's not done. And I wasn't even aware of it until I consumed the book Writing Software, spelled with a R, Rightting, space software by Javal Lowy.
Okay.
And it revolutionized, can't say the word, revolutionized the way that I approach managing the software development effort.
Um, where do I even begin? First
Attack.
of all, I don't agree with the way, like you said, organizations do it, where they just say, everybody, big bang, start writing code, right? I don't agree with that, obviously. But I also don't agree with the big design upfront, right? That's what you just described, where an architect will sit down, design the entire system, and then people start implementing it. That's also bad, right? In my experience,
Why is it
I have
bad?
seen, I'll tell you, in my experience, I've seen both projects fall apart. In fact, I would even argue that the second approach of the big design upfront is worse than everybody start writing code. The reason for this is that everybody start writing code has the advantage of one, you can quickly get executable artifacts, right? It's possible. I'm not saying it's a good design. Like I said earlier, I also hate that approach. But that approach has the advantage of at the end of the, whatever you call it, you may have something that sort of kind of works, even if it's badly designed, it's a terrible user experience, etc. But at least something came out of it. The problem with big design upfront is that, and trust me, I've seen this, is that you bring architects, they come in, they look at the system, they scope it and write all these interesting abstractions. And Any little deviation, any little change, any little assumption that is wrong in that big design tends to cascade the bigger the design is. So for example, if I'm designing a system and I make an assumption, no matter how small the assumption is, subsequent design decisions rest on top of that original assumption. And
Nope.
what tends to, I'm getting somewhere. And what tends to happen? What tends to happen is by the time it gets to the point where you've started implementing the thing, you now realize that the reality is very different from the assumptions you've made. And the bigger the design you have up front, right, the more disastrous those assumptions will become. Okay. So what's your rebuttal to that, before I continue?
It may not be a rebuttal, but I would I would argue that we need to define what it means to design. We need to define what it means to architect.
Exactly. So let's get our terms correctly. What is the design, in your opinion? What is the difference between architecture and design?
I think architecture is making and enforcing decisions that are extremely challenging to revert once done.
Okay. Then how
I,
is that
I,
different from design? Yeah.
I think design is a is a how would I a, a design is a manifested, it's not even manifested. It's I might have to look up Webster's dictionary what design is, because the reason why I'm struggling with defining design is
Mhm.
you can look at a tea kettle with
Okay.
a handle that you just put your index finger in, and
Mhm.
that's a design, right? It's something that is focused on it's a plan that is severely focused on completing an objective.
So
That's how I would that's
yeah,
how I
so
would define a
my
design.
definition is completely different.
Okay.
Okay. Architecture has to, what you said was correct in the sense that it's usually decisions that are made that are difficult to change. That is true. But there are also design decisions that are difficult to make. But architecture has to do with how components of a system interact with each other, right? It has to do with the overall framework of how things are put together. The design is the specifics of the function, the form, and other things of how that thing works. So, for example, the architecture of a house, right, is how the layout of the house is. Is it a two-story building, one-story building? What are the rooms inside, and so on and so forth, right? The design of a house has to do with the specifics of, okay, this is going to be the kitchen based on the architecture. And this kitchen, okay, we're going to have taller doors, shorter doors, and so on and so forth, right? That is the design. Now, another example I can give is a, a human being, hold on, a human being and a human, a mouse, and an elephant all have the same architecture, but they have different designs. So they all have the same architecture in the sense that we all have hearts. The heart is in the center. We all have brains that take blood flow from the heart. We all have what's the word? Two hands, two legs. You understand? Like we all have four limbs and a few other things, right? But the design, the specifics of an ant, or sorry, of a mouse and an elephant are different. Elephants have long trunks, they are larger, they have skin, and so on and so forth. But the architecture, how the components of the being are put together, is functionally the same.
It's the
Does that
same.
make
So how
sense?
it does. I'm curious how that's different from me saying that it's a plan for achieving an objective. That's what I said the design was. So when you take different species of animals, right, or just different types of animals, an
Yeah,
elephant, a human, a mouse, yes, they have the same architecture. They have one brain, they have two lungs. Um, I think the examples that we gave, they all tend to be mammals, right?
yeah, yeah.
However, a mouse, the form factor of a mouse, its design is for feeding on small things. A mouse doesn't have the
Correct.
same, it doesn't have the jaws of an elephant, right?
Correct.
A mouse is
Yes.
designed to be a bottom feeder, right?
Hmm.
That's the objective is to, for any life form, the
Yep.
objective is to survive,
Hmm.
right? And so you have these manifestations of these different creatures in which they're designed to survive based on the form factor that they were given.
But but
In
but
conclusion,
yeah,
I don't see what the difference is.
when you said that, right, you have to understand that both the architecture and the design are necessary to meet the objective, right? So the a better way to think about it is, and this is a very bad example, but a better way to think about it is that it, the architecture is like the abstract class, right? And then the design is like the concrete implementation of that abstract class. Now, I hate
Okay, that's really
OOP,
good.
but yeah, I hate OOP, but I hope I'm able to like explain what I mean.
Yeah, we were on the
Right?
same page. Yeah,
Yes.
I'm glad you articulated it that way. Yep.
Yeah. Yeah. So from that perspective, right, when you think of software architecture, right, software architecture is very easy to define because it is not concrete, right? It's not concrete uh to the domain that you're building it for, right? Then those decisions are easy to make upfront. So decisions like, are we using microservices, or we're not using microservices? Decisions like, how do we plan to um how do we plan to split deployments? Do we have rolling deployments? Those kind of I don't think the deployment on matters per se in software architecture, but you kind of get what I mean. The software architecture is what strategy do we want to build the system. Now keep in mind that the architecture has nothing to do with the domain. So you could use the same architecture that you're using for you know online shopping to build law, you know uh, um a legal software or accounting software or things like that, right? The specifics is the design. So the design kind of has to cater to the domain. Like you said earlier, when you a mouse is designed to feed on small animals.
Dude, like
Hmm.
the more that you break it down, the more it is to me, design is nothing but implementation details. The When you hold a mug, the implementation
Uh-huh.
details is you have the handle, you have the cylinder that's
Hmm.
hollowed out.
Yeah.
Those are the implementation details. That is a
Mhm.
design
Yeah,
for
that's
drinking.
actually correct. Yes, 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 yes. You're correct about that. Yes.
Okay.
So that's well, where I would like to still split it separately from the code is that the implementation details and the implementation are not necessarily one and the same, right? You could have the implementation details, maybe is more tactical. It may tell you do it exactly like this, but the details of how you do it can differ. You get what I mean? So you have the architecture that is just vague. That just says you need to have a brain, a heart, you need to have a nervous system, you need to have this, you need to have that. Whether you want to make however you want to now make the details of your animal, right? You want it to be a mouse and be built like a mouse, fine. Then the implementation of it is the specific mouse. Some mice have longer whiskers than other mice, but they have whiskers, right? The whiskers would be the design, right? The architecture is what we've discussed earlier, and then the specifics, the length will be like the actual implementation of it. Does that make sense?
It does. I think we're being a dead horse now.
Yeah, yeah, yeah.
All
So
right.
so moving on, right? Back to what I was saying earlier, the idea that you would come up with the design upfront, I think is just terrible. Now you can come up with the architecture upfront. You could design the
I
architecture.
said you designed the project. Those were my words.
Oh, okay. You design the project, but that's the architecture. You architect the project.
No,
Is what you
no,
wanted to say.
no.
So
There,
that means your design would have like the implementation details. Is that what you're saying? We
let me
just
explain. Let me explain.
okay. All right.
You you have you have two design
Mhm.
documents, right?
Okay.
You have the architectural design,
Mhm.
you have the project design. Okay?
Okay.
The architectural design is going to, at a high level, identify the strategy for achieving business objectives, business mission for whatever solution that needs to be built. And it, in theory, should identify, and this is what I captured from the book Writing Software by Jabal Lowy, and I totally agree with it. Uh, Obviously, it has its place, right, based on the size of the project, but
Mhm.
you identify the in the book it's called the areas of volatility, right?
Okay. Mm-hmm.
Areas that areas of the solution that as time goes on could affect the architecture or could affect the business. Well, architecture is not affected. Architecture is in place regardless, right? But that will affect the business.
It could still affect the architecture, right? And I think that's the whole point of think about it. That's the whole point of coming up with an architecture is the right architecture shouldn't change depending the right architecture should identify the areas of vulnerability and design around it such that even down the line when the project has moved along, nothing is going to be able to alter it. Now the design may be altered multiple times, but the architecture should remain the same. Now if you don't architect your system properly, then as time goes on, conflicts could come in, and those areas of volatility, if they were not properly identified at the beginning of the project during the architecture stage, they will affect everything. They will affect the entire project, everything, right?
So my argument is,
Hmm.
and I could get attacked. I'm opening myself up. I'm vulnerable, right? My argument
Yeah.
is on a organizational project, on a software project that is being managed by an organization, the architecture is set. Everything else is refactoring the implementation details to make that solution work. No matter you could write hello world, that was architecture. You can hack together code, with spaghetti. That's still architecture. You can refactor the hell out of it, right? But that's really the implementation details. If the definition, if there's a consensus that architecture or is architect singular or plural, architecture is a set of decision are a set of decisions that are difficult to revert
Hmm.
once implemented,
Hmm.
then yeah, architecture is already in place.
That's for projects that already exist, right? That you're coming into. Those are the projects that already have the architecture in place. For brand new greenfield projects, there is no architecture to deal with,
You're
right?
designing the architecture.
Yes, but that's for
You're,
greenfield projects, right?
yeah, but once you start, okay, I'm listening.
Yeah,
Yes,
yeah.
but the
So,
whole point of
so,
architecture is
mhm,
to put the abstractions put the abstractions in place
yes.
that is realized as feature enablers as code,
Hmm.
right? It architecture should compile somewhere. You could view architecture as a collection of modules that
Hmm.
are arranged with some type of thoughtfulness,
Mm-hmm.
I think we're saying the same thing.
Yes, we are saying the same thing. So we're
Okay.
actually in agreement. So anyway, let me just go back to what I was saying earlier. When what started this whole conversation was, you mentioned something about, companies that just want to just go ahead and write code, everybody, and there are also other, you also talked about, you preferring that, the developer or somebody, an architect, come and architect the solution upfront. But the word you used was design, and that was where I took an issue to it. So, right. So with design, not so good, but with architecture, sure. Right. And the reason I say this is that, like I said, the vaguer, I won't say the vaguer, but the more abstract your architecture is, the less likely it's going to have to change, right? um, is going to have to change as a result of the development, the development and so on and so forth. And I was explaining that the reason why that is a bad idea is because any assumption that is made, no matter how little it is, right, it's like a building block in a Jenga tower. The moment you make an assumption, you forecast, because that's what you're doing when you are designing, right? You're forecasting, okay, this is how this thing is going to work, and you're going ahead to design it. Any assumption that is wrong, there will be other assumptions that are based on that assumption. And by the time you start implementing, this is which goes back to the problem I have with the whole design up front, is by the time you start implementing and you now discover that one of the original assumptions is wrong, then all of a sudden the ripple effect now causes you to have multiple cycles. It's the same reason why we stopped doing hold on. It's the same reason why we stopped doing waterfall, was because the idea that I would design, I will architect, design, start implementation, test, and deploy is just wrong. Because what happens is you architect, you design, you discover things that are issues with the design that need to change the architecture. So you're now moving back one step. Then you architect again, design again, but now you are implementing. You now discover new things during the implementation that's wrong, that may need you to change your design. And if it's really, really bad, it will need you to change your architecture again. So you see how this cascades, and it's almost like a recursive algorithm, O of n or something like, or O of n prime, where you now notice that the timeline for the project grows exponentially the closer you get towards the finish line. And then anybody who is making estimates is giving a wrong estimate, because their estimation is based on how much effort they've made and how far they think they are closer to the finish line. So long story short, the proper solution is, yes, you can architect upfront, but that architecture is like trying to lay out the framework of what you're building. And then each individual design is done as part of a cycle, right? So you pick a feature, you design just that feature, implement the feature, and ship that feature, no matter how little the feature is, right? I'm not even talking MVP. I'm just talking about just one feature. And then you get feedback on that feature. If it's good, if it makes sense, it doesn't make sense, you can go back and then do your design again. But that design is only scoped to that one feature. That is the proper way to do it. Any other thing is just going to get you in trouble for the reasons I mentioned.
I that is a option. That is a strategy, but it's not one size fits all. And the reason
Okay.
why is because many organizations that have a budget of a large amount of money, right, or AKA they have big budgets for a project,
Yeah.
they need sign-offs, right? They need a plan for how that money is going to be consumed, how that budget is going to be consumed on that project.
Correct.
They want an estimate of how long it's going to take to deliver that solution. And so the example that you recently provided, it doesn't fit into that type of organization that has a big project in which there needs to be sign-offs. It doesn't.
So it's good you mentioned that, because that's precisely why we were because I told you I worked with Theorem where we were consultants, and we were brought in to a very large company to do exactly that. It has to do with the expectation, right? That's the wrong expectation. The wrong expectation, and that expectation comes from corporate or whoever it is, where they just assume, give us a date when this project will launch, right? So that we can sign off and then give estimates on that date, right? A fixed date. The problem, like I just outlined all the problems with it. The problem with it is if you make all those assumptions, any little change, any deviation whatsoever is going to cascade up, and then you enter multiple cycles of development, right? So what used to happen was one way of solving this problem was the the way the company was structured was you had this team that would first go in and do something called discovery, where they would look at the entire workflow, look at the entire process, not build anything, right? Just try to discover as much of the domain as they can. It's almost like a search party looking for something, right? And what they would do essentially is try and figure out every minute detail of how of the environment in which they're building this software, right? And once all that is done, it's at that point that the architecture is now finally done, like we said earlier, where they break it and say, okay, from this to this point, and so on and so forth. And then rather than giving whoever is the stakeholder a finite date, the stakeholders are given milestones for individual features. You get what I mean? And whatever estimate, just hear me out. And the expectation that's given to management is whatever estimate you people have, right, is going to be based on individual features. So it's not a case of if the company comes and says, hey, we want this thing to be ready by say December, 6 months, or whatever the case may be. See, you can keep your estimates, you can keep your timeline. What is different is what gets delivered at the end of that 6 months. That's the variable. Your timeline can be fixed, but what gets delivered becomes the variable in it. Does that make sense? Rather than fixing the deliverables and then fixing the timeline of the project, that's just disaster.
I agree with with what you're saying. I think the hang up that I have is how organizations are set up in the real world.
Correct.
Organizations are set up in the real world by relying on sign-offs, by wanting to know how much something is going to cost so that they can get funding for that project. They have to dot their I's, they have to cross their T's. If this were some other type of system um, of, of of how people organize around a project, what you're saying makes sense, and I think it would have a higher success rate. I do. It's a lot easier to estimate projects that are smaller compared to projects that are 3 times, 5 times, 10 times bigger, right? It's
Mhm.
a lot. It's more manageable to focus on smaller pieces and etc. The issue is again, there are deadlines. Some deadlines are fabricated. Other deadlines are based on partnerships with other organizations in which they will be penalties. There could be penalties by governing bodies, hence government. There could be penalties with a business partner, aka another corporation that's partnering with you, in which they could be adversely affected, and that could cause public relations issues. That could cause the Dow Jones or the Nasdaq exchange to have unfavorable consequences.
Mhm.
Right? There's factors to this, and so
So
that's why people want a plan that they can review, they can butcher, they can uh, implement feedback from that review, and just iterate until there is a warm and fuzzy feeling, or AKA confidence. before we move forward. Like I don't think you could. I don't think that system is going to be replaced.
So again, right? You need to, okay, so let me explain. And it's good we're having these conversations because I can bet you it's not a new problem. And 99% of software engineers, software projects go through this precise problem. And I have been in so many failed projects. I have not just that I've been in so many failed projects, I've also been in successful projects as well, just say. But I have tried being both an engineer in a project, working as a team lead in a project, even working as a manager of a project, right? I've seen all three sides of this problem. And I can, I have a very clear understanding of what the issue is. Now, if you're building anything that's worthwhile, right? Any software project that is worthwhile, it's like going to a place you've never been to before, right? You don't even know how to get there. You just know it's somewhere in this vicinity. But the specifics of how to get there is to be determined. That means that no plan, no matter how good you are, no matter how unless you're building a piece of software that has already been built before. If you're building a piece of software from scratch that hasn't been built before, which is 99% of most projects, right? You don't know where you are going. You don't even know how to go to where you're going. You don't even know how long it will take to get to where you're going. That is the problem. This means that no finite plan is going to be accurate because it's almost like an archer trying to shoot, right? Even the slightest of deviation, the farther away the target is, the slightest of deviation is going to guarantee a miss. Now, how do you manage this thing, right? Because, like you said, businesses
Let
are
me let
doing
me
what they're
interject. Let me interject before you move on.
okay.
Having a plan
Mhm.
reduces the probability of failure. It doesn't get rid of it, but it reduces the probability. It drops the percentage points, I would argue. No, it
I
doesn't.
st- I still disagree. So yes, it does reduce the probability, but the probability that your plan is going to work out of the gate is almost zero. I have
I
never, I have never, in my 20 years of experience, I have never seen, I have never been in any project where developers came together, regardless of skill level. You could be talking A-list developers, all of them. Sit down, plan a project of sufficient complexity upfront, and that plan, as is, works from start to finish.
that's I understand what you're saying and you're right. What I'm trying to drive is again, executive leadership, they want to know how much it's going to cost. In order to understand how much it's going to cost, they have to know what the timeline is going to be, right? How much
Yeah,
time is it going to take,
yeah.
right? Who are the ones that we're going to? How much are the people that we're hiring? How much do they cost,
Yeah.
right? It's you you. I'm not sure how you can give them a estimate that is reasonable without demonstrating due diligence of methodically uh, performing analysis on what it means to deliver a solution. I 100% agree with you that there's going to be things that what Donald Rumsfeld said in essence, and it's not verbatim the quote, but there's things that we know, there's things that we don't know, and there's things that we don't know that we don't know. And there's also
Correct.
miscommunication with just human beings,
Yeah.
right? In which we
Mhm.
misinterpret one thing for another. So I get that. I 100% agree with you. That still does not negate the fact that someone wants to know how much it's going to cost before the project commence.
So again, you're correct. So what I would recommend in those situations is, like you said, somebody has to give an estimate. How long would this take? What's the cost estimate, and so on and so forth. A good way to plan is to break the instead of breaking the project by instead of breaking the project by phases, which is what I'm fighting against, the projects could be broken by features, which means that whatever arbitrary deadline you give, right, you will have something tangible. There will be something in production. The app would be delivered, quote unquote. The variable is how much of this software will be delivered. That's what I'm getting at, right? So rather than slicing the application, or rather than slicing the phases in horizontal fashion, you are slicing it in vertical slices, so that if you and your estimate, what you would give your business owner will be based on how many slices are we looking at, how many vertical slices of this application are we planning to deliver, how long is a slice going to take, how long do we estimate all these slices will take, right? And then those slices will now be broken up, will now be scheduled by, in a waterfall form, but instead of horizontal slices of, oh, we architect the whole system, we design, then we build, then it's going to be, we architect authentication, we build it, we spec it out, we do everything, and authentication will be delivered in 3 weeks, for example. And then we now look at, okay, this feature or that feature, but feature by feature. And tying it with what we discussed earlier, you could now have dark launches, right? You could have feature flags that somebody can switch on to enable specific features vertically.
I
So
know what you're saying, Odie, and I
yes,
think we're talking
so
past each other.
okay.
What you're saying is optimized for delivering value.
Mm-hmm.
I acknowledge that. Every problem is, in general, a people problem.
Yeah.
It's the organization that needs to be re-architected, right? And sadly, that organization already has its own architecture that's hard to revert. And so maybe
Then
maybe that's the conclusion. No?
yeah, so you again, you're right. What happens to those organizations is that every new project they embark on ultimately fails, right? Because their structure doesn't support, isn't their structure isn't conducive, right, to following the right isn't conducive to following the right culture, the right uh, 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 yeah, the right culture to promote good software practice or software engineering or whatever. I don't know how I'm butchering it in my brain,
I
but
would try to rephrase it as the the architecture of the organization is not optimized for quickly iterating on planned features and well, I'll just stop right there. Iterating,
yeah,
right? The whole point of
yeah,
iterating is to continually refine until it's good enough, right?
correct, correct,
And I mean,
correct.
organizations, I would say they they have their own architecture in which they're not conducive to certain things that really are needed by the business because
Mhm.
of politics, because of antiquated policies. I'm okay
Yeah,
ending it right here, Odie.
yeah. One advice I would give, right? Because to the people who are watching, if you're a tech lead, if you're an engineering manager, a project manager, one trick that has worked really, really well for me when dealing with antiquated businesses where they want a deadline, they want a specific date, and this has worked well for me is I do so when I'm planning software projects, right? I do it the way I just described, which is I create vertical slices. I give estimates for how many vertical slices is going to be, how many sprints or whatever do I feel, again, it's not a personal thing. You have to work with the team and get, their feedback and look at previous things that have been done. And anyway, once that roadmap has been done, stick to your roadmap, right? So if it's 6 months, tell them 6 months. Now they will push back and be like, can't we have it done in 3.5 months? Or, oh, the customer says it must come in, 4.5 months, or this is the deadline, and so on and so forth. That's fine. But what you do is, like I said, vertical slices. So even when that deadline, whatever arbitrary deadline they put, even when that deadline is hit, it won't be a case of you guys didn't deliver anything. It will be a case of there are still features that are missing, right? And of which, if you do your due diligence very well, if you follow agile, processes and so on and so forth, after each vertical slice is delivered, right, there's going to be some kind of backlog refinement where the product owner, whoever it is who's the representing the customer, will prioritize what feature should come next. So hopefully by the time you've gotten to whatever the arbitrary deadline is, most of the major features have already been shipped, right? Maybe there are a lot of niche features that are still pending, and yes, customers may not like that, blah blah blah, but at least it's better than zero. It's better than the alternative, which I've seen happen so many times in projects, which is you come up with your big design, it's perfect, everybody is happy with it. You start developing, and then you run out of time. Maybe you run out of time during development, or you run out of time during testing, and you have nothing. You've not delivered shit to the customer. The customer is upset with you, and at the same time, you still did not meet the deadline. So it's like you lost in all dimensions, right? Um, Now, my to wrap up, because I know we've really gone over time, but my experience doing this was I tell management this is when this thing will be ready. They push back. I reluctantly agree. It ends up taking the exact time that I told them it was going to take anyway, right? It registers with management that Odi pushed back on this, and it ended up being exactly what he said. By the time I had done 3, 4, 5 projects that way, when I gave the estimate for the sixth project, for example, and I told them this is going to take 4.5 months, they didn't even push back. They just said, okay, fine, we'll find a way to persuade the customer to say 4.5 months, because there was a history of being able to deliver within the ballpark of whatever timeline I gave them originally, right? And once that you've built that reputation, right, you build trust with your management, and they start to trust you towards giving that flexibility of having sprints and the whole agile process and stuff like that.
I still think that there needs to be a discussion on design and architecture, because you still have areas of volatility. You still have third-party frameworks, libraries that deprecate.
Mm-hmm.
You still
True.
have governing bodies that have mandates that you need to be able to adapt to, right? Hence abstractions to basically be applied to all these volatile areas.
Mm-hmm.
The way that we security mandates, etc.
Yeah.
So,
Yeah, but that's something that we could have in a different discussion. How do you come up with a good architecture, right? What are the things you need to do? Like you said, identifying areas of volatility, very important. Another thing too that is also very useful too is going through a discovery process, and that discovery process could involve building a prototype, for example. No matter how little that prototype is, one takeaway from all of this is the quicker you can invalidate your assumptions, the better it is for any software project, right? The quicker you can quickly realize that, okay, we made an assumption and this assumption was false, whatever can shorten that time is going to provide the highest amount of value, right? So yeah.
all right, call to action, Odie.
Yes. So if you liked what we discussed about today, uh, you know, comment in the just comment in the down below. Let us know your feedback on this. Have you ever been in projects where things went badly? What do you think caused it to go badly? As stuff like that. Yeah. So like and subscribe as well. Over to you, Scott.
We're approaching 140 subscribers.
Yeah.
Keep it going. Yay.
Yeah.
So, all
Yeah.
right, that's it. Take care.
All right.